Hello everyone. Today we are going to review radicals in preparation for your test. So I would encourage you to pull up the blank lesson that goes along with this and try the problems, like pause the video for each screen and then come back and listen to the explanation as we go through. So slide A here, let's simplify the radicals using the product rule. So try questions 1, 2, and 3. Do your best. If you don't know how to do one, then just do the ones you can. Okay, so product rule, we're trying to find two numbers that multiply together to get 300, and one of them has to be a perfect square. Well, 100 is a perfect square, and 100 times 3 makes 300. Then we simplify by using the product property and taking the square root of each independently, separately, and so your final answer would be 10 square root of 3. Question number 2 is kind of using the product property in reverse. Now when we have these two square roots multiplied together, neither one of those is a perfect square, so we're going to put them back under the same radical and multiply them together. And that gives us a square root of 96. Then, do we have a perfect square that goes into 96? So we check our list of perfect squares and we can see that 16 goes in there 6 times. So now we have our perfect square, 16, the square root of 16 is 4, and then we have the square root of 6, which is not a perfect square, it would be a decimal. So now we get 4 square root of 6, that is our final answer. Once you get to that point of simplifying, always check to see what's under the radical and make sure there are no more perfect squares that go in there. And then this last one is pretty simple. When we put them back together under the same radical, we just get the square root of 35, which I'm pretty sure you can do in your head. There are no perfect squares that go into 35, so that one is simplified. Okay, let's go on and use the product rule with variables now. So pause the video and try these 3 questions. Remember, with variables, all even exponents are perfect squares, so we're trying to break them up into an even exponent and then one left over that might stay under the radical. So give these a try and then turn the video back on when you're done. So I always look at the number and the variables separately, and there is a perfect square that goes into 116 because 16 times 10 is 160, and since this is x to the 4th, that's just going to be cut in half. Now, I wrote them out originally, each of those variables. You can go back and doing that into writing x squared times x squared. So now I give each of the factors their own square root, and the square root of 16 is 4. The square root of 10 stays under the radical, but the square root of x to the 4th is x squared. So we get 4x squared, square root of 10. There are no more perfect squares that go into 10, so that is simplified. In this next one, we have to look at what goes into 124. And we always try to look for the largest factor, perfect square factor that goes in there. But in this case, the largest one is just 4. So I have 4 times 31, and then I have x squared times x. So I'm going to take the largest number of even exponent I can get out of there, which is x squared, with 1 left over. And then I'm just going to leave y to the 10th as is, because if it's even, we can just cut it in half. That will be a perfect square. So now I give each factor their own square root sign, and I take the square root of each piece individually. And when I take the square root of 4, I get 2. The square root of 31 stays under the radical. The square root of x squared is x, but the square root of x stays under the radical. And the square root of y to the 10th is y to the 5th. But now we clean that up, and we take everything that's on the outside, like the 2 and the x and the y to the 5th, and we put them together. So the final answer here, cleaned up, would be 2x y to the 5th times the square root of 31x. So we put all the things that are outside the radical together and all the things that are inside the radical back together. And on this last one, we would multiply these together, and 10 times 2 is 50. And then we'd have x to the 5 plus 4, 9th power. So now we will see, is there a perfect square that goes into 50? Yes, 25. So 25 times 2 would give us our perfect square factor. And then x The largest number of x's in here that would be an even exponent would be 8, and then times x. So now we take the square root of each individually, and that gives me the square root of 25, which is 5, times the square root of 2, times x to the 4th, times the square root of x. So now I take the 5x and x to the 4th, put them back together outside the radical, and the 2x inside the radical. By the way, keep in mind that we are going to be doing a test where you're going to actually do your work and show your work right on the Schoology test. So you will need to show some work on almost all the problems. So keep that in mind. Make sure you're not just giving the final answer. Even if you can do some of this stuff in your head, we want to see your thinking. Okay, we're going to move on to slide C. So if you can pause the video and try these, and then start the video when you're ready to see the answers. So when we have a fraction, if either the numerator or the denominator are perfect squares, then I would just take the perfect square. So in other words, number 1, the square root of 225 is 15. So we have 15 19ths, and that's really just our answer. Okay? If both pieces are under the radical, we can see if we can reduce first. But if one of them is a perfect square, I probably would just take the perfect square first anyway. But when we take 160 and we divide it by 2, we get the square root of 80. But then we always have to look, is there a perfect square that goes into 80? Yes. 16 goes in there 5 times. Then we take the square root of each piece individually, and that gives us back to 4 square root of 5 for our answer. Hopefully you've done some of these so many times you're starting to get the hang of it, because we keep having the same, numbers like 80 and so forth that we have in these problems. Okay, on this last problem here, the square root of 196 is a perfect square of 14. So what I have is 3 and then times 14 over 2. And 3 times 14 is 42. When we divide that by 2, we get 21. So our final answer here is 21. All right, we got, I believe, 2 more slides here. So let's work through D. Again, pause the video, try these questions on your own, and then start the video and see if you got them correct. So again, we're doing the same thing we did on that last slide, but we are variables as well. So in this first one, the square root of 81 is just 9, and the square root of x to the 6 is x to the 3rd. So those are already perfect square factors. Then we have that divided by 3x, but now we need to reduce this. So 3 goes in here once, 3 goes in here 3 times, and that's not a really great color. So I end up with 3 over 1 for my number part, and then this is x to the 3rd and this is x to the 1st. We subtract when we have a common base and we're dividing the variables, we subtract the exponents. So our final answer here is going to be 3x to the 2nd. Okay, next one. Okay, now both the numerator and denominator are underneath. So if I take 90 and I divide it by 5, that gives me 18 for the number part. And then I take x to the 15th over x to the 8th, I subtract those exponents, I get x to the 7th. But now there are perfect squares underneath there. So 9 is a perfect square, 9 times 2, and for the variables, this is going to be x to the 6th and x. So again, now I take the square root of each of those factors individually, and the square root of 9 is 3. The square root of 2 has to stay under the radical, but the square root of x to the 6th is x to the 3rd, and then we have finally the square root of x. Again, I put the numbers outside back together, so this is 3x to the 3rd, and I put the numbers underneath the radicals back together, multiply them back together, and put them underneath. So there's our answer for number 2 on D. And for question number 3, this right here has a perfect square. So this is going to be 2, and then the 45 is 9 times 5. X to the 10th is a perfect square, so we can leave that over 3x to the 4th. So now I'm going to work on that top. the numerator and take the square root of each piece. So now that gives me 2 times the square root of 9, which is 3, times the square root of 5, which is underneath the radical still, times x to the 5th, all over 3x to the 4th. I'll clean this up a little bit, which would give us 6x to the 5th square root of 5 over 3x to the 4th. Again, I need to reduce that like a fraction. Okay, 6 divided by 3 is 2, and x to the 5th over x to the 4th, we subtract those exponents. So what that's going to give us is 2x times the square root of 5 when we're all done. Okay, and here's our last slide on rationalizing the denominator here. And so again, pause the video and come back, see if you're getting these correct. When we simplify radicals, we cannot have a square root in the denominator of the fraction. So what we do is we multiply by whatever that square root is over itself. That just has a value of 1. We're really just multiplying by 1. So what that gives us now is 8 square root of 2 over 2. But then again, just like before, this part right here is just like a regular old fraction. And 8 divided by 2 reduces to 4 over 1. So this would just become 4 square root of 2. And that would be our answer. Okay, on this second one, okay, you could put those back together. And that's what I would do, because I noticed that I could reduce the 8 over 10. So if these were under the same radical, it's just going to give me smaller numbers, and sometimes it might work out easier. You don't have to do it this way, but 2 goes into each of these. So what that gives us then is it gives us the square root of 4 over 5. But then we have to separate them, and so this becomes the square root of 4 over the square root of 5. I can't have a radical on the bottom, so I'm going to multiply by the square root of 5 over the square root of 5. And that gives me the square root of 20 over 5. Now, you might think you're done, but the square root of 20 still has a perfect square factor. So we have to separate this into 4 times 5 over 5. And so what that gives us, when we take the square root of 4, we get 2. So now what we get is we get 2 square root of 5 over 5. And that's our simplified answer. Question number 3. We have the square root of 8 on the bottom. Now you might notice there is a perfect square that goes in there, but a lot of times it's just going to be easier if we just do that at the end. You could do it first, but I'm just going to do it at the end. So now what we have is we have 3 times the square root of 8 times 5 underneath, or 40, over the square root of 8 times the square root of 8 is just 8. So now the square root of 40 has a perfect square. 4 goes in there. So this is going to be 3 times the square root of 4 times 10 over 8. So now take the square root of 4 and 10 separately. And what that gives you is 3 times 2 times the square root of 10 over 8. Or that gives us 6 square root of 10 over 8. But the 6 and the 8 can also reduce like a fraction. 2 goes into both of those. So then we get 3 square root of 10 over 4. So there's a lot of the properties that we learned and rules all play a role into each of these rationalizing the denominator problems. And last one, question number 4, we're just going to multiply by the square root of 7 over the square root of 7. So we get 63 square root of 7 over 7, but 63 and 7 reduces to 9 square root of 7. All right, so I will be available for questions for this test, so feel free to email me questions. There will also be some extra credit so that you can do some extra practice on some of these things to make sure you're prepared for this last test. Have a great day, everyone.